Welcome to our second video on the topic of supply and demand. In the first supply and demand video, we looked at what makes up the demand curves and the supply curves, why they're shaped the way that they are, using examples of football game tickets. And then we looked at the concept of supply and demand equilibrium and why it is that price and quantity tends to settle at an equilibrium of supply and demand. What happens if the price is away from equilibrium and what market forces move it back there, and the forces that make all that work. So what we're going to move on to in this video is what happens in situations where things change supply and demand. We're looking at shifting demand curves, shifting supply curves, and therefore changing equilibrium. And what all this does is to give us a model of how prices are determined and change over time in real market systems. I'm sure you've noticed over time that the prices of things tend to vary based on a whole variety of different forces out there. We can explain a lot of this through this supply and demand model and help some of what you see in real life make some more sense in that way. So I'm going to use a similar example to the one that was used in the last video. We'll stick with the football tickets. We're now in fall of 2013, so we've changed the time frame a little bit on what games are coming up. But for our examples today, I'm going to go to the upcoming Indianapolis Colts football season. I'm taking us to here on the StubHub website. StubHub is a great illustration of market systems and of prices shifting and changing, and supply and demand changing over time. So we'll probably look at it several times during the semester. What I've got pulled up in front of us right now are the Indianapolis Colts games, home games for the fall 2013 season. And we see these games mostly at a similar price if you're just looking at the quick glance of, priced from the starting price, I guess you could call it, and the number of tickets available. For most of these games, we're looking at a starting price of $26.20, and it goes up, of course, depending on how good the tickets are. Except for this one game here, which you might have noticed already. The starting price on this one is $188.99, and if you look over to the left, you'll quickly see why that is. That is the Sunday night Denver Broncos at Indianapolis Colts game, and if you're living in Indianapolis, you're probably aware that will be the first time that Peyton Manning returns to Indianapolis after leaving for the Denver Broncos last year. So prices are obviously going to be higher in this market for that game. We can use the concept of supply and demand to talk about why that would be the case. So let's go back to our demand curve, and we'll look at both supply and demand factors here and see how that might affect it. So the concept of a changing or shifting demand curve means that if you're changing demand, and we're going to define this as a change in demand is one where the quantity demanded is higher or lower. The quantity demand is different at every given price. That's a change in demand. And here's our example using these numbers. Let's say that instead of 5,000 tickets demanded at a price of $350, the number of tickets demanded at $350 was 7,500. And let's go down the line and say that the quantity demanded is 2,500 higher at every price. So I'm going to call this quantity demanded 2. And just add 2,500 to each of these values of quantities demanded. So now what we're saying is at a price of $350, the quantity demanded is now 7,500. At a price of $300, quantity demanded is now 8,500, and so on. If we were to graph those numbers, the demand curve would simply be further to the right than it is now. We'd call that new curve D2, and we'd show that shift with an arrow shifting out to the right. And so that shift is an increase in demand. The shift is an increase in demand. Compared to D1, we've increased demand to D2. We want to distinguish a shift in demand from a change in quantity demanded, or what's called a movement along the demand curve. This is a thing that's kind of a nuanced, tricky concept that the AP test loves to make sure that you know. So I'm going to put it this way. A change in demand is a shift, D1 to D2. A movement along the demand curve is one where you've got a change in the quantity demanded because you're putting it at a different price, but the basic relationship between between price and quantity remains the same. So for instance, here's P1, P2, Q1, Q2, and we're moving along the curve. If we were to say that P1 is 350, that we were going from a price of 350 to a price of 300, decreasing the price, we're moving along a given demand curve, increasing the quantity. Let's go back to our original demand. We're increasing the quantity from 5,000 to 6,000 as we drop the price from 350 to 300. A shift, or a change in demand, back to what we're focusing on here, is when you change the quantity demanded at every price, and therefore you shift the curve to the right. So there's a change in demand. Let's go back to why would this happen? What does this have to do with our Indianapolis Colts, Denver Broncos, Peyton Manning example? Well, there's a number of different factors that will shift the demand curve. And the main one that I'm thinking of here that relates to this is going to be a pretty obvious one. It's the fact that this particular game people have much more of an interest in going to see than any of the other ones on the schedule. Our book outlines 4 different factors that tend to shift a demand curve for any good. And this, what we're talking about with the Denver Broncos game, would fall under a change in tastes. So in other words, if people want it more, so if we increase the taste, and economists would say if we increase the taste or preference for this good compared to what it would have been before, or say compared to other similar goods like other different football games, if we increase the taste or preference for the good, then we're going to increase the demand for the good. We're going to shift the demand to the right. People are going to demand more of it at every price because they want to buy it more. Pretty obvious, but that's how economists would call that. It would refer to that as a change in taste or preference for the good. Some other common things that can change demand, different from the example we're now using. We're not using the Colts example anymore. Say that general incomes in Indianapolis changed. If you increase people's incomes in general, then you're going to shift the demand for most goods to the right. I say most because we're going to now classify 2 different kinds of goods. We shift the demand to the right for what are called normal goods. Normal goods are defined as those whose demand increases when people's incomes increase. There are some goods where if people's incomes go up, the demand for those goods decreases. And examples of those goods would be anything that people tend to buy more of when they're on a tighter budget. Generic items, any number of examples of that. And these are called inferior goods. And these are rarer than normal goods, but they certainly exist. So that's how changes in income tend to shift the demand curve. Changes in prices of related goods, we're going to define again a couple different terms here. Some goods would be known as substitutes, and other goods known as complements. Let's go back to the Colts game example for these. A substitute for a Colts game could be any other kind of event that somebody might do instead of going to a Colts game for leisure, sports entertainment, whatever. So say that during the Colts season, people are choosing between going to a Colts game or going to a Butler basketball game when those seasons overlap. If the price of the substitute good goes up, say the price of Butler basketball tickets goes up, people might be less likely to spend their money on a Butler basketball game, more likely to spend their money on a Colts game, therefore, and so the demand for our good, in this case Colts tickets, would go up. And vice versa, if the price of Butler basketball tickets dropped, then people might say, I'm going to go to less Colts games and go to more Butler games because now I can go to more of them, get more benefit out of them. Complements are the reverse. If the price of a complement good goes up, then the demand for our good is going to decrease. An example of a complement to a Colts football game would be parking around the Lucas Oil Stadium. If the price of parking increases, then that might cause some people to demand Colts tickets less. They demand less tickets at the same price because they can't afford as much anymore. They have to buy the parking along with the game, so the demand's going to go down if the price of something you have to buy along with it goes up. Lastly, the factors that shift demand are changes in expectations, and mostly this refers to expectations of future prices, future price changes. So if consumers were to expect the future price of a good to fall, then we can assume that they might wait to buy the good until later, so the demand for the good now would also fall. And vice versa, if they expect future prices to rise, then the demand for the good now might rise, which we'll see in a minute has a little bit of a ironic effect of raising the price as kind of a self-fulfilling prophecy. So there's our main factors that shift demand. We'll do a lot of examples in class of what happens in this market if this kind of thing happens, and you need to be able to explain that'll, as a result of people's income increasing, people will buy more of it because now they have more purchasing power, etc. And we'll work with a number of examples of those. All right, now let's look at the supply side and shifting supply curves. So remember, the suppliers of tickets are those who are holding tickets and are thinking about selling them. And again, if we want to do a shift in supply, just like when we define a change in demand as the quantity demanded being different at every price, a change in supply is what happens when the quantity supplied is different at every price. In other words, at a price of 350, maybe instead of 8,800 being supplied, you'd have 10,800 being supplied. Call this QS2. And I'll just go ahead and add, let's do 2,000 to each of these. 10,500, 10,000, 9,000. In real life, it's not necessary that you'd have the same amount, same increase in quantity supplied at every price. I'm just doing that to make it simple. Usually you're just kind of given this information. It's not something you usually have to calculate or come up with. So if we were to illustrate that on this graph, again, if we graphed those values, then we would just have a supply curve that was shifted out to the right of this one. Draw an arrow to the right, call that S2. And that is an increase in supply. Once again, we have the same kind of concept in a supply curve. A movement along the curve is different than a change in supply. A movement along the supply curve is when, along a given supply curve, a change in the price changes the quantity supplied, changes where we are on the curve. So P1 to Q1, if we increase the price to P2, then we'd increase the quantity supplied to Q2. That is just another statement of the law of supply, which you read about or learned about in the last video. Label our axes here. Okay, but now let's go back and focus on shifts in supply. What tends to shift the supply curve? What causes somebody to offer more of this good even at the same prices they would before? Or probably more realistically, what causes more suppliers, more individuals to get into the market? And now with Colts football tickets, let's talk about it in that way. What would cause more people to want to sell their tickets at a given time, even at the same price? If there are originally 8,000 people willing to sell their tickets at a price of $250, what kinds of things would make it so that all of a sudden 10,000 people would now want to sell their tickets at $250 compared to before? So here's the factors that can typically change supply. It's really easy, I think, to remember with supply. It's always about the costs of producing it. So changes in input prices. Input prices just refers to the costs of production. Our ticket example breaks down a little bit here because there's not really a cost of producing a ticket. There's a little bit. Let's say that there was a cost of putting things on StubHub. So let's just pretend for a minute so we can use it as an example. If it, say that StubHub charged, I don't know, $100 for you to put your tickets on StubHub. That means if you are think you're going to get, what you want to get out of your tickets is $250, then you've got to charge $350 for your tickets. But then if the cost of putting stuff on StubHub decreased by, say, $50, now instead of having to charge $350, you only have to charge $300. And if you can sell your ticket for $250, then even more people are going to be in the market. Bottom line is, if the cost of production for any good decrease, then the supply is going to increase. The supply is going to shift to the right. And vice versa. If the cost of production increase, then the supply of the good is going to decrease. So what we see up in this, when we shifted from Q quantity supplied to QS2, we could assume this could have been happening because the cost of production was decreasing. Therefore, more people now think it's worth it to sell it for $250 than they did before. 10,000 people will now make a profit off of $250 as opposed to 8,000 people making a profit off of it before. Technology, it comes into play here in the same sense that cost of production do. That technology, essentially we're talking about technology of producing it. Technology of production. And generally better technology of production lowers the cost of production. So I'm going to put it this way. Better technology in the production process tends to increase supply, tends to shift supply to the right. And then you've got an expectations factor in terms of future prices again with supply. If suppliers or potential suppliers expect the future price to rise, then they're likely to want to wait until the price rises to sell, maybe just hold on to this good for a little longer. So we'd say the supply now would decrease if we expect the price in the future to rise. So there are our main factors that shift supply. So shifts of supply and demand, that concept works in a very similar way. What you usually have to do is identify, okay, is this factor that's happening in this market something that's going to shift the supply, something that's on this list, or something that's going to shift the demand, something that's on this list. Easiest way to do it typically is to think, does this affect the producer and the producer's cost of production, or does it affect the consumer and something that goes into the calculation to the consumer of how much they want to buy or how many people want to buy this good or how many people can afford to buy this good, because remember, demand is both wanting it and being able to actually pay for it. So there's our shift factors. Now, putting all this together into equilibrium, what we're going to see is that when you shift the curves, this is pretty easy to understand, so I'll do it rather quickly here. Say that you were to increase demand on this equilibrium page, and say that we were doing this, I'm going to go back and use our numbers that we came up with up here. I added 2,500 to each of the quantities demanded. I'm going to do that here too. Quantity demanded 2. Again, these are the same numbers as above. I'm adding 2,500 to each of the demand values. And here is this curve now is a fairly bad drawing of the numbers I've put over here. So at this with this new shift in demand, we've got a new equilibrium, and I didn't make it line up very well, but you can also see it in the numbers, and it's important to be able to see it in the numbers because you need to be able to identify it both on the graph and with a table like this. Remember that the equilibrium originally, change color here to go to, let's say this is the original equilibrium. Here you can also find here at a price of $250 where quantity demanded equals quantity supplied, 8,000 at a price of $250. That's an equilibrium. But now with the new demand curve, that is no longer an equilibrium. If they keep trying to sell it at $250, you're going to have, remember, excess demand or a shortage, and that is a market force that drives the price up. So now with our new demand curve, I'm going to identify the new equilibrium in green. It's where now the quantity supplied equals the quantity demanded here at the price of 300 instead of at a price of 250. So that should correspond to about 300 and a quantity of about 8,500. So in other words, if the shift in demand were to happen in real life, you would see probably momentarily, depending on how efficient the market is, how much information is available to producers and consumers quickly, a temporary kind of shortage of the good, until producers figured it out that we can raise our prices and still sell more. The new equilibrium will settle at this new price, the new equilibrium price of 300 and 8,500 sold. This also helps to explain why the somewhat counterintuitive thing that you see on here on the Colt back to the StubHub is that even though this game has a much higher price to it, starting price, there are more tickets available, more tickets being sold, and likely there will be more tickets transacted on StubHub for this game compared to the other games. Stadiums are not perfect examples of this because they got kind of a set number, but still, the number of transactions on the StubHub can vary. So the point is that you can have, with an increase in demand, you increase both the equilibrium price and the equilibrium quantity. And here's a simpler way without the numbers, and this is the way we'll most often see these problems, is just by kind of making sketches of the graphs and showing what the impact is of a change in demand. So this could be a visual of if you increase demand, the result is you've increased the equilibrium price and increased the equilibrium quantity. A typical problem that would go along with this is, so say that the price of peanut butter, PB, increases, and this is the market for jelly, quantity of jelly and price of jelly. The price of peanut butter increasing, peanut butter is a complement to jelly, we can assume. So remember, an increase in the price of a complement is going to decrease the demand for jelly. So the demand for jelly decreases, which is the opposite of what this graph shows, but there's one where demand decreases. If we wanted to do one that goes along with this graph, let's just switch it up. Say that the price of peanut butter decreases, leading to an increase in demand for jelly, which leads to an increase in the equilibrium price and an increase in the equilibrium quantity of jelly, as you can see there on the graph. That's just, you draw this graph and show this kind of cause and effect chain in one of these problems, and we'll do some examples of that in class. It's pretty straightforward, and there's basically just 4 different combinations, right? You can have an increase in demand, which increases equilibrium price and increases equilibrium quantity. You can have a decrease in demand, which decreases equilibrium price and decreases equilibrium quantity. Sketch that out if you want to prove that's true. And then on the next slide, you've got changes in supply. If you've got an increase in supply, as shown on this graph, you end up decreasing the equilibrium price and increasing the equilibrium quantity, whereas a decrease in supply will increase the equilibrium price and decrease the equilibrium quantity. When you're just shifting one curve at a time and holding everything else constant for the moment, which is how we most often see these problems, you basically just have those 4 possible combinations if you're going to isolate it to just go with one thing that's happening at a time. So that tends to be pretty simple, and you can just kind of get to know the graphs of each of those. It gets slightly more complicated in problems, and we'll see some of these, where we say, what if a couple different things are going on at the same time? What's the outcome? So in this example, you can see that we're both at the same time increasing demand and increasing supply. Oops. Increasing supply. Don't be fooled whenever the arrow is kind of downward on supply. Sometimes there it looks like it's decreasing, right? But remember that a shift to the right is always an increase, and a shift to the left is always a decrease. Okay, so in any case, we've got an increase in demand and an increase in supply. We know that the quantity is going to increase because the effect, the individual effect of both of these, we've got an increase in price, increase in quantity from demand, and a decrease in price, increase in quantity from supply. These just correspond with these options up here. In other words, an increase in demand is pushing the price up and it's pushing the quantity up. An increase in supply is pushing the price down and it's pushing the quantity up. So since the quantity is going up from both of them are pushing the quantity up, we know the quantity is going to increase. And you can see on this graph, you see the quantity increasing by quite a bit. But we've got counteracting forces on price. So what it comes down to is whether the price ends up increasing or decreasing depends on which of these is stronger. Which of these increases by more? Does demand increase by more than supply? And that's what happens in this graph, because the price ends up increasing, which tells you the demand shift was more than the supply shift. So we'll see problems like this. It tends to ask, how do you know, like, what do you know is going to happen and what is indeterminate? And this one you'd say, out of these two forces happening at the same time, for instance, say an increase in tastes and preferences and a decrease in production costs. Increase in tastes increases demand, decrease in production costs increases supply. What do you know is going to happen? Well, we know that quantity is going to increase. Whether price is going to increase or decrease depends on which of these is stronger. Okay, we're going to stop it there. We'll do lots of examples of this. This is a kind of a pretty fundamental thing, but I think one that's very manageable. Look forward to talking it through with you in class.